Hello everyone, this is Mr. Mullicash. This is our week 16 video for Math 172 for Johnston Community College. If you're watching this video, here's my email address. If you have any questions, shoot me an email. You can also use the discussion board online. Today we're going to talk about parametric equations. Should be exciting for you if you're watching this and you're in my Math 172 class. This will be the last video of the semester. Woohoo! All right, so without any further ado, let's see what a set of parametric equations are. So no doubt you're familiar with y as a function of x. You spent a whole lot of time in Math 171 learning about these different kinds of functions, linear, quadratic, polynomial, exponential, logarithmic. In this class, sine, cosine, tangent, and so forth, right? So in these kinds of functions, x is the domain variable. We'll call this the domain variable, and we'll say that y is the range variable. And y depends on x, so we say that y is a function of x. So x is the domain and y is the range. Okay, a similar kind of thing happens in polar coordinates, where r is a function of theta. So you can put different thetas in for your domain. Sorry about my chicken scratch here. And your range value is r, right? Okay, so you put different, angles in and you get different r values. And functions that are the rectangular equations, your ordered pairs looks like this. And over here, the range variable is listed first, kind of odd, and then the domain second. So this is all sort of a review of what you've already learned about. All right, what parametric equations do is you're still going to use x and y, not r and theta, so you may be happy to know about that. But in parametric equations, both x and y are both range values. They're both range values. Now you still get to graph x's and y's, but they're both range values. So you might be asking, well, what's the domain? Well, the domain is a third thing, and we're going to call it t for now, but it could be called something else. And t is called a parameter. It's called a parameter. And, oftentimes t is time as a variable that represents time. But it can also be an angle or slope or that kind of thing, right? Just some other outside influence. So what that means is that x is a function of t and y is another function of t. And these two equations together are called parametric equations because both x and y are defined in terms of a parameter. So that's the gist of what parametric equations are. So let's take a look at an example where we might be able to put in some t values and then get some x and y values out. And then once we do that, we'll be able to graph what we have. Keep in mind now, the only thing that appears on the graph out of these equations are still the x's and y's. Okay? All right, so here's an example. Let's say that we have x equals t plus 1 and y equals t squared. And we'll let the t variables, we'll let t be on the interval from 0 to 3. So what that means is we're going to have a chart, much like you may have used like in middle school or high school, or Math 171 even, where you have a domain variable, so you have different numbers that you can put in for the domain variable, and then you have to put these in in this case, two different equations, right? So let's put 0 in for t here. 0 plus 1 is 1. If we put 1 in, 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So you can see all the x's are all the t's, but just add 1 to all the t's. Okay? So what we have now is a set of x coordinates. All right, to get the y coordinates, we do the same thing. Over here, we have to square all the t's. So we have 0, 1, 4, and 9. And now what we're going to do is we're going to take these as ordered pairs and graph them. And then we'll sort of connect the dots. Okay, so on the back here, I've got some graph paper. I'm just going to flip this over. And this is from our prior video that I forgot to erase. So let me get rid of all this conic section stuff. All right, so what were the ordered pairs again? I've already forgotten. 1, 0, 2, 1, 3, 4, and 4, 9, right? So 3, 4, and 4 all the way up here to 9. Okay, so what's happening is this is what looks like part of a parabola. Now on this graph, I'm going to put an arrow. This arrow indicates what might be called the orientation of the curve, which is really just the direction in which the curve is traveling. Okay, so you might be asking, like, where are the t values? Well, the t values are marked for each point. This is when t is 0, this is when t is 1, this is when t is 2, and up here is when t is 3. You don't have to put these on the graph, but knowing the order in which you put the points helps you find the direction that the curve is traveling in. Okay, so in a way, this is like a curved vector. You know, vectors are straight line segments with an arrow on the end, but this is like a you know, these are sometimes called vector valued functions. So that's kind of what's going on there. So the graph comes from the table. Again, we're only going to put the x's and y's on the graph, and we're going in the direction from t equals 0 to t equals 3, because that's the restriction of the domain. Okay, so here's another set of parametric equations. So let's say we have x equals t plus 1 and y equals 2t minus 5, right? And let's say that we want to take these two equations and we want to combine them into a rectangular equation that has no t, just x and y. So there's a way to do that by eliminating the t out of both equations. And so here's how you do that. You can replace t in one equation with what t equals in the other one. So for example, if I solve this for t, I get, you know, we can subtract 1 from both sides, right? So t is equal to x minus 1. So that means that I can put this in the place of that t in the other equation. I can do this substitution, right? Okay, so then what we have, you know, you can leave it like this. This is the equation of the line, but you can also, you know, just keep on going here and combine like terms. So this is the line 2x minus 7, and obviously we know how to graph that. This is the y-intercept, -7, the slope is up 2 over 1, and you draw the line, right? So there is a difference between parametric equations, though, and a rectangular equation. Here, remember, x is the domain and y is the range, and there's no restriction on x at all. So the domain for this function is all real numbers. All x's can be put in for x. All real numbers can be put in for x, and you can get the entire line. Excuse me, I bumped the camera there. With these equations that we started with, okay, if we remain in parametric mode, if you will, there has to be a restriction for t values, right? So you have to, you know, be given an interval for t's to put in there, and then, you know, you have part of the line and it would have a direction, sort of like a vector, okay? So that's the difference between, you know, rectangular equations and parametric. One more thing I want to leave you with, and I don't have a computer screen up here, and apologize for that, but if you were to go to Desmos Calculator, and let me just kind of remind everybody the website for that. So that's desmos.com/calculator. Okay. When you go to that calculator, you can graph parametric equations. So I'm going to write here how to do that, and I'm going to trust that you go to this website and actually try this out for yourself. And in the video description below, I'll put a link that will further explain how to do this. So what we're going to do is we're going to go back and okay, let's say we have x equals t plus 1 and y equals 2t minus 5, right? Can't remember if I had plus or minus in the other one, but in any event, let's just say that these are your equations. And we'll let the t's go from 0 to 3, like we did before, okay? So in Desmos, what you would do in the box, there's a little box here, it's probably colored blue or red or something like that, and then there's a box like this, and then there's an X there, right? So you can like completely get rid of anything that you put in there by clicking that X. What you'd have to do is you'd have to put in parentheses t plus 1 as the X coordinate, and then 2t minus 5 as the Y coordinate. Now when you do that, if you're doing that maybe in another tab or something while you're listening to me talk, if you do this, as soon as you type this in, the box will get bigger, and this will turn out to be a curve, and it'll be some kind of color, like mine's red right now. But in any event, what will pop up underneath this is a blank here, a T, and a blank here. Well, you can put in 0 in that spot and 3 in that spot to indicate the restriction for the domain variable, right? So if you do that, then what will happen is you'll get part of the line that would otherwise be y equals 2t minus 7. Let's see, 2t minus 7, 2x minus 7, my bad. Okay, so if you were to graph this in another thing, if you were to put y equals 2x minus 7, you'd see the entire line on the screen rather than just a line segment, right? And so the entire line would be there covering up the other one in a different color. So just a little added bonus there, that if you wanted to graph parametric equations in the Desmos calculator, you can, but you put in the x equation in the x coordinate of an ordered pair, the y equation goes in the y coordinate, and then you have to restrict an interval for the domain variable t, okay, which is called the parameter. All right, well, I hope that you have enjoyed watching these videos. This is the last of the series. Please do send me an email if you have any questions, and thanks for watching.